And now for the exercises for this chapter. We're going to read in this actor one column, so we have some strings to play around with. So which actor one has appeared in the most movies? Can you write an expression that returns the actor's name as a string? Okay, so actor one, what we're going to do is just call value counts on it. And you can see here it's Robert De Niro, but so that's great. He appeared in 48 movies. How do you get his name? Well, you can get the index of that like this. So the index just grabs the index that we're looking for, and then we can get 0. The first item in the index is Robert De Niro. What percent of movies have the top 100 most frequent actors appeared in? This sounds a little tricky. So we're going to, let's see here. So this is all of the actor ones. There's 2,095 of them. They're sorted because I'm using value counts from the highest to the least. So if we do dot head of 100, let's get the first 100. These are all the movies that they've appeared in. If we sum this up, this is the total number of movies that the top 100 most frequent actors have appeared in. And then we can just take the length of actor one, that's the total number of possible movies, and we'll get this percentage. So they've taken place in 32.5% of the movies. How many actor ones have appeared in exactly one movie? Okay, again, we're going to use value counts here. We want to see how many of these actors, so there's 2,095 of them, how many have appeared in one movie? So we're going to set this, we're going to test whether or not this equals 1. So let's give us a Boolean series. And then all we have to do is sum this up. And so 1,379 have appeared in exactly one movie. How many actor ones have more than 3 E's in their name? Okay, so here's where we're going to use our string-only methods. We're going to count the number of E's like this. And we want to see how many have more than 3. So I'll put a unique array of just these actors. So we can do dot value counts like this. Now, the ones that have 3 or more are this number. So this is one way to do it. But let's just see. So we can assign this to a variable. Let's just call it S. And here's one way to do it. We can test more than 3. So that means either 4 or 5. So we can see how many have more than 3 or 4. So this is this will test. We're going to test whether an actor has more than 3 E's. Call this filter, and actor 1. We'll just filter just for these actors. So you can see here. And then how can we get a unique array? Well, we know the unique method like this. So this is how you can get all of those actors that have exactly, or not exactly, have more than 3 E's. So they have to have 4 or more. So Jennifer Lawrence, there's 1, 2, 3, 4. Keanu Reeves, 1, 2, 3, 4, and so forth. So you can verify them by hand if you want to. All right, number 5, get a unique list of all actors that have the name Johnson as part of their name. Okay, so actor 1, let's read that. We're going to use the contains method. And do they contain Johnson? We'll assign this to filter. And actor 1 will filter down for these actors like this. And we can do dot unique. This time I'm going to do dot drop duplicates. And this will be it. So the Johnson can appear anywhere in the name. It doesn't have to appear at the end. It just happens that all of them have Johnson as their last name. All right, number 6. How many unique actor 1 names end in X? Okay, so this is kind of interesting. Actor 1 dot str. There's actually an ends with method. This is the same thing as in normal Python. So we'll do this. Again, we'll assign this to filter, and then we'll use this to filter out like this, and then we will again drop the duplicates. So these are all the actors that have a last name or just a name that ends in X. All right. Number 7, the Panda string methods overlap with the built-in Python string methods. Find all the public names that are in common to both. Then find the public methods that are unique to each. Okay, so let's say, so the panda string methods, how do you do this? How do you get a list of them? So we know if we press tab, we can see them over here, but to get them programmatically, you need to pass it into the dir method right here. And we don't want all of the, we don't want the ones that are private, the ones that start with an underscore. So what we're going to do is, we're going to do a set. We're going to create a set comprehension here. We'll say name for name in dir if name starts with, we don't want it to start with if not. So this should do it. Okay. So this is pandas string methods. And then we'll do the same thing for Python string for, instead of actor.dir, we'll just do dir of str. Okay, so now we have two sets here, and these are all the public methods. So the ones in common, we'll just use the intersection like this. So these are all the ones in common. And then the ones unique to each, you can use a minus sign. So we'll find the ones unique to pandas are over here. So these are all the ones that are unique to pandas that don't exist for Python. And the other way around is just to do subtract out the pandas like this. And these are the ones unique to Python over here. Okay, so pretty cool. Using some built-in set operations and then the dir and also this set comprehension as well.